नमस्ते बच्चों, हमेशा खुश रहो बच्चों। Myself Om Prakash Kesari, Faculty of Department of Mathematics under Faculty of Education and Methodology, JAYOTI VIDYAPEETH Women's University, Jaipur. Today I taught you group theory, in which I will see some theorems on subgroup of a group. The group theory is the subject which are taught in BSc BEd PCM 6th semester students. These are the lesson planning which are already discussed in your previous lecture. These are the steps for planning a lesson which are already discussed in your previous lecture. These are the component of a lesson plan which are already discussed in your previous lecture. Now group theory. In your last class, I will see the theorem prove that the identity element of a group is the same as that of the group, in which I have constructed a group. Let G star be a group and let H star be a subgroup of a group G. Then if possible, let E and E dash be the identity element of G and the subgroup H of G respectively. Then we have to prove that E equals to E dash. For this, now take any element A belongs to H. Therefore, this implies that A star E dash equals to E dash star A equals to A. Since E dash is the identity element of H, this implies that A belongs to, again, this I will take this as equation 1. Again, A belongs to H. Again, we will take A belongs to H. This implies that A belongs to G since H is a subset of G. When we take any element in H, which are also in the element in G. Now, this implies that A star E equals to E star A equals to A. Since E is the identity element in G, take this equation as equation 2. Now, from equation 1 and 2, we get A star E equals to A star E dash from the left side, and from the right side, E star A equals to E dash star A. Now, from this left side part, we will cancel left A. That means cancellation law, left cancellation law. And from the right part, we will cancel right A. That means right cancellation law. Therefore, finally, if we cancel left A, we got equals to E dash, and right A, we got equals to E dash. Finally, we got equals to E dash, which are comes from the left cancellation law, cancellation law in G. Hence, this implies that the identity element of a subgroup is the same as that of the group. That means identity element is the at least one element in a group G. Identity element at, at least is the one element which are exist in a subgroup G. Sorry, H of G of a group G. Now the next theorem, we have to prove that in the next theorem of subgroup, the statement is the inverse of any element of a subgroup is the same as that of the inverse of the same element regarded as the group. Regarded as the group. That means exists a uniqueness of inverse in subgroup. Uniqueness of inverse identity element in subgroup I will already see. Now I will see uniqueness of inverse in a subgroup. Prove that the inverse of any element of a subgroup is the same as that of the inverse same element regarded as an element of the group. That means we have to prove that the inverse of any element of a subgroup is the same as that of the inverse of the same element regarded as an element of the group. Now, the proof of this theorem is let G ring sum be a group and H ring sum be a subgroup of G ring sum. Again, let E be the identity element of G and H as well. Now take any element A belongs to H and let B be the inverse of A in H. That is A inverse equals to B belongs to H. Now, this implies that A ring sum B equals to B ring sum A equals to E. Again, A belongs to H. We will take this as equation 1. A belongs to H. This implies that A belongs to G since H subset of G. Let C be the inverse of in G. That is A inverse equals to C belongs to G. This implies that A ring sum C equals to C ring sum A equals to C. From now taking this equation as equation 2. Now from equation 1 and 2, we get A ring sum B equals to A ring sum C and B ring sum A equals to C ring sum A. Now from the first part, we cancel A from left, and from the second part, we cancel A from the right. That means when we cancel from A from the left, we got B equals to C with the help of left cancellation law. And when we cancel A from the right in this equation, we got B equals to C from the right cancellation law. That means finally we got B equals to C by using the cancellation law in A group G. Thus, it follows that the inverse of any element of a subgroup is the same as that of the group. That means we can say H follows the inverse of an element of a subgroup is the same as the inverse of the same element regarded as a group. Hence the theorem. Now, in your next class, I will see one more theorem, which are the necessary and sufficient condition for a non-empty subset H of a group G to be a group, which are related to the necessary and sufficient condition or foundation in G of a group. The proof is similar. I will see this theorem in your next class. This session is powered by the digital version 2.0 JAYOTI Vidyapeeth University, Jaipur. And I hope all of you are satisfied with my digital session. If you have any queries, please mention in the comment box. I will try to resolve it. Thank you for watching my this lecture video. Thank you, everyone.